Ladies and gentlemen, welcome to my presentation, Smart Lighting in Helsinki. This is a part of LUCI Seoul Asian Open Lighting 2020. My name is Olli Markkanen. I'm the head of unit of Helsinki Municipal Engineering Unit. So, what is Helsinki? Helsinki is the capital city of Finland. This is also the biggest city here in Finland, and Finland is a part of the northern Europe, a part of Fenno-Scandinavia and we are a part of European Union. Helsinki has about 650,000 inhabitants, and the metropolitan area of Helsinki has about 1.5 million inhabitants. Our neighbor countries are Russia, Sweden, and Norway. And over the sea on the other side is Estonia. Yes. Finland and especially Helsinki is a very fast growing city here in Europe. I know Asian cities are growing fast too and faster than European cities, but Helsinki grows quite fast. And here are some areas where are the new areas coming. And here on the eastern side there is a new harbor, and all the old harbors are brought to the new harbor. There are some cities in Europe which are known that they have gained new area by moving their harbors to one new place. So like Hamburg and Helsinki would be also one of them. But first to the history of illumination lighting in Finland, of which we are very proud of. We had the first lights 1772 and 1782 for our king's crowning. And at that time we were part of Sweden, and of course the king was Swedish and so on. The first street lights were oil lamps. They were in the year 1880, and the first real lighting networks was a gas lighting network, like in all big cities the situation was. And the first electric lighting network, or like if Helsinki was 1877, this was one of the very first lights. And this was actually a couple of years before Edison's one invented the in-cascade headlamp. Partly illumination came the next summers, and of course street lighting too. The first ones I think was 83. 1909 our city did a smart move and combined all the small private networks into one communal electric network. And at that time we got also our communal start with electric outdoor lighting, and before that was more like gas lights, and those small parts of electric lights were just in parks or harbors, not so big. But then we jump 100 years to the future, where I come also to the game, and our Helsinki Energy is one of the big electrical power companies here in Europe. So after EU law, it has to be privatized. Of course, it's still a part of the city 100%, but outdoor lighting networks are now in the city side. So we are at the city. And there was structural change 2017. The outdoor lighting was integrated into the Municipal Engineering Unit, where also the traffic lights and other city technology are there. Like, for example, street heating we do need, and like here in the old picture we wouldn't see any snow anymore, since there is nowadays a street heating. We have lots of snow of course in Finland, but not on those streets where we do have heating. So of course with this municipal engineering unit where I'm the unit manager, outdoor lighting is of course the biggest thing still. And some facts from this year: we have 92,000 lighting points, 23 employees, and we are a member of LUCI, of course, and UV7. UV7 means outdoor lighting 7, which are the 7 biggest cities or big cities with outdoor lighting in Finland and the state. And we have been since the 70s together. And we are, I don't know other systems which are like this. In Sweden, there is one copy of UV7. Yes. Outdoor lighting in Helsinki, here are some facts on the slide. Of course, 1877, which we are very proud of. We could also mention 1999, where the first lights on the streets, and I think they were also the first ones on the streets at that time. And at our latitude, the yearly dark time is shorter than 4,000 hours. In Lapland, it's like 3,500 hours or even less. In summer, up in the north, it's also exotic for us in Lapland. You can see the sun also at midnight all the time. The sun goes never down. It's really exotic for me too if I'm with my family there. In Helsinki, we have like 3 hours of darkness. The climate in Helsinki can be in the summer normal, warm, plus 30 C. I know in some parts of Asia you will still freeze at that temperature perhaps. But then we have also cold temperature up to -40. This is of course hard for the technique, and we do have lots of snow. In some winters it's a big problem since Helsinki is a half island towards the Baltic Sea, and before it freezes the moisture comes up of the sea and we have lots of snow. So we do need lots of money and trucks to remove the snow, and if big machines pull the snow away, we lose also some cabinets. Like 1 year we have lost like 100 street lighting cabinets and other cabinets, and perhaps also smaller cars. Anyway, we do have electric networks for the normal electrics and separate for the outdoor lighting, and they are built with the principle N-1, which means if we lose one component like a street cabin or there is a cable failure, we can bypass the faults by building the networks in rings, and we can the other way bring the electric there. So we can bypass the fault to repair it in the summertime when there is no ice, when the soil is not frozen. As I told, our network grows since the city is growing every year by about 1,000 light points. But last year we grew by 2,500 light points. We had also a couple of tunnels, and there are always lots of points, and they give us much work too, and you have to be really smart with those too. So greetings to Singapore. We had a really good time checking your tunnels. Yes, well, of course we have a citywide lighting control system, and we can also feed every feeder of the streetlight cabin, like for example in Dubai, and with we use Zigbee to get contact to the different luminaries. I would say these are the basic system if you want to be a smart city. Nothing special there, I guess, for many of you. But what does this smart city actually mean for Finns and for Koreans, since we have this 4G, 5G industry? It of course means 5G and phones and that kind of dimming. But what is this? If it's only dimming, it actually means that we reduce the quality of the light. We only take light away. Okay, it's smart and we save the world since we are also saving energy. But what does the customer get there? What is the beef? What is the beef for us? How does the work for us easier? Is there something smart? I try to give you some answers in my presentation there, so we can know what is smart or efficient or so. It's much more than only dimming the lights. But of course, as I told, due to our special situation in the world here on the northern hemisphere, really high, the sun goes up and down during different times in the year. So in the middle winter, there is only a short time if there is light, and in the summer there's almost all the time light. And here you can see how this is presented on the slide. Then how do we how do we manage our network with the smart way? We have separate computer systems, and they have been there a long time. Like I've been here with the lighting over 30 years. I've been here a long time. Our network information system has been 30 years in use. Our documentation system is there. Everybody has a documentation system. We have building system, maintenance system, mapping systems. We create all the time new systems, and we have for everything systems, and we try to make the data flow and operation control automated. That's rule number 1. And rule number 2, that we do have mobile access to these data, the services. Of course, nowadays with apps. But these lights are already quite long, done like 5 years ago or 10 years ago. So we knew these things, even 20 years ago. And these systems are mostly Finnish systems, and we had a key role to get them done. So yeah, the important things, but here on the right side, the picture is a picture of our center. This picture is already 20 years old, and is from the year 2020. And we won with this lighting the Edison Award in USA. It was the biggest award at that time. We were quite surprised to get an award of this, the best award of lighting. And we had lots of guests at that time, and we had to show all the places there and wondering that this is a beautiful place even today, and I love to go there, walk, and there are lots of tourists there. Of course, not now with the corona, but if there wouldn't be corona, people would have their coffee and so on. And yeah, okay, back to the smart. So we have a network information system. Actually, we do have two of them. One is Trimble. Trimble, we know, of course, Trimble and Tekla. Bridges all over the world are done with this kind of calculation system of Tekla, and all the Olympic stadiums are done with these systems. And of course, why not the electrical network? And I know this Finnish-based system is also here in Asia, in some cities, in big cities too. So we are happy to have them, and we're happy to have in Finland lots of computer skilled people that we can have these. Then we have a building management system. This Loiston management system, it's for work management system. We come back to that. And the key product system is also a Finnish system, and there are lots of different subsystems there. The newest one we have for our traffic lights, we have also a system, of course, and then for our optical data network fibers. We do need data network mostly for traffic lights and smart traffic, but lighting is a part of it, of course, and lighting needs to be controlled too. And this old system, data fiber, is a smart one. It's basically made of stones, and glass is made of stones, so it should be a little long. But of course, the optical fiber doesn't go all the way to the city, and 4G, 5G, and is now 3G, 2G, 2 there, and it's also cost effective there. Then we have a mapping system, had like 5 years, and it's really practical, since the better you know, the better you can automate your mapping, the better you find your cables under the earth and soil, and the other ones won't harm them if you can say where they are. And then we have also maintenance management system, and let's go to them. Here's a picture of the Trimble network information system. This is an old one, and like here in the pictures, I calculated 20 years ago the whole network, and thought we need a big electrical subsystem here. So of course here's also all the power needs to go there, but where do you build it? But nowadays it is there. It's like minus 40 meters below these houses. There is also a big artificial lake under the there are like heat accus for the winter, and then there are cold accus for the summer. We have also a district cooling and district heating system. We have all the stuff here in Finland, Helsinki. They're like nerds. And then there is a picture of our building management system. It has been that already 20 years in use, and we can calculate all the tenders and which contractor do we need. And then we have the pictures of Quentic there. Quentic is the app for this building management system. Perhaps you know it's an international software. We can take pictures and download these through our building management system. We can download them to the documentation system. Everything is integrated and automated. Here is the pictures of our Quentic system for the contractors. And then the other network information system is here. Pictures from the same place, from Esplanade, lots of luminaries there. And the mapping system on the right. Here's the maintenance system. When I 15 years or 16 years ago thought we need to be faster than we were. We had the normal stuff, 2 or 3% of the lights were dark, and we had a promise that it takes like 6 weeks that some fail is maintenance. Nowadays we do this integrated. It takes less than 2 days. I think now it takes 3 days. If there's a storm, it can be, of course, a little longer. But our failure rate was this month 1.17 or something. So we were quite close to 1%. I would say that is a really short time. And this is the failure system for the customer. It's now tried to do very simple that everybody can show our faults. Here you can see the situation now. The green spots are the fails which have been already repaired, and the yellow ones are which are today underway, and the orange ones are for tomorrow, and the red ones are fails which haven't been produced anything. Of course, there are many more functionalities in this. Yes, and there are some statistics. The 3 spikes there were the 3 first years when the cars didn't have computers at that time, 2005 and 2006. And then they both computers and it went in faster. Then some pictures of Helsinki. As I said, Helsinki is a beautiful city, as you can see. And with this slide, I always want to show you what is good light. Of course, it has to be economical and ecological. We need to save the world. It's the thing, if you come to this kind of seminar, you talk all the time. But you need to remember that there is also the city beautification and all the stuff there is. I added there some you need to take care of. So don't, this dimming is only one part of it. One good part is this color adaptive road lighting or lighting. And I had this idea like 5 years ago, but nobody wanted to produce for me this light. So I had to search far away. And on the other part of the world is, for Helsinki, it's New Zealand. And one company from New Zealand, Orangetech, wanted to do it. So as you know, it's practically quite easy to produce this kind of light. If you take about Dali, there are actually 4 addresses, and we only use one. But if we use 4 addresses, we can dim like green, red, whatever light color, temperature, or color you want to. You can make even an RGB spotlight with this system, and it's very cheap to do it this way. So not a big idea. Here's some principalities of this human-centric lighting. I know you had this already yesterday, so I don't want to spend your time talking about that. But I just wanted to say that, like, when our kids go to the school and when they're over 4 hours in this 4,000 or 5,000 G, they become too active and almost aggressive. So you need to have warmer color. And we know that the breast cancer of women comes from this. Unless they're blind, they don't get it. So this blue light can be quite dangerous too. And if you think about men's prostate cancer, it looks like our killer number 1 has also this problem with the blue light. And then it needs more studying this thing, but there is something there. The first thing I did this yellow and white light was 15 years ago when we built this super big harbor. This has like 100 masts, 40 meters high. It's as big as Helsinki center, actually. It's a big area. This harbor is mainly for Russian trade. So there is a sodium lamp and metal halide lamp. And I did it actually to have quality and that is cheap. As you know, for stadiums, the metal halide lamps cost like over $200. But now, if with 2 lamps I could use those tomato lamps for the greenhouses, they cost like $20. So it was just to do it cheap, but it was a way to do it smart. Yes. And with art, we can have 2 different kind of colors. Here's a thing, a Finnish Helsinki Lumina producer did it for us. I wanted to have optics with 1.5 degrees, and then you can have the floodlight really far away or the spotlight. So then you save also a pole And it's not nice if there is a pole in front of the art piece. And since we are removing the snow too, it's better to have not so much poles. And the really nice thing was to find with this kind of material, if you use like 3000 Kelvin and then or 2500 or 4500, you have them from different directions. There comes a special effect, but it's I can't tell it to you. You have to try it yourself. So this is one thing you can do smart way. And the one smart here in Finland is if you do this, you have to have good clothes too, that you are not in a cold. Then this old oil harbor. Now there's coming a new area there too for housing. We left one old silo there. We made 2012 hosts there, since Helsinki was the design capital of that year. And with this, we got also all the prizes in the world. This is a really beautiful masterpiece, and the designer was a Finnish guy, Tapio Rosenius. He works nowadays in Spain. I would say this is a masterpiece, and it looks really beautiful there. It's in the archipelago. Finland has thousands, hundreds of thousand islands, and islands too, and we all have summer houses too, and like our own lakes. Finland has been like 3 years now the most happy country in the world. I don't know why. We are cold and dark, but we have lots of space. Finland is as big as Germany from the space, but we are only 5 million people, so we have lots of space and our own islands. Everybody. Well, must be funny for you. Yeah. Okay. I think my time is over, but you can check my slides and make questions. I know you had this color adaptive lighting yesterday too, but I would say it was a success. It worked technically really good. 2 points I would have done here. Next time when we do this, we have already a couple of practices. We could do this in parks and then have better atmosphere there. And with art pieces, of course, this is a nice thing to have the exact right color, and it doesn't cost any more than normal actually. And the other point is that in this we made also master thesis there, and actually nobody saw that the color temperature was changing, but everybody was saying, "Oh, the light is nice and it's so beautiful," and so. But nobody actually saw that it was the color temperature. And there's some problems which are with normal LED too. If you put them in all poles, the streets are wider and narrow, like 10 meters to 25 meters, like in this project. So you have to think it over. But since you from auto lighting, you would have also the same problem. Yes, and we have a dimming table too. That's the first step in the being smart with all the lighting glasses. That's the main beef for dimming. But as we talked, there was much more. And now the light with the different kind of colors here, it looks like. How does it look here on the street? As you see, it goes from cold to warm. Of course, the atmosphere is very, very different in 5000 Kelvin and 3000. Here are the first interview conclusions and some measurements, of course, how the situation is there. Yes. And then back to the center of Helsinki, this is an old, between harbors and old space, there was a railway before, or a rail, yes, but now, as you see, there's nobody there. There's some kind of fear factor there, yes. It's something we don't want to do. Perhaps this should be a little bit warmer, yes. Virtual reality, we already showed in the seminar AGM LUCI 2015. This was also one of the first ones in the world. This was even before Intel made these virtual reality computers, so it was hard to look those pictures. But this huge bridge we are building to this half island from eastern part was mostly done with this kind of design. We have done lots of designs with this. The special of this is that we can have the real surfaces, so we can do calculations which are going to be really exact in the last place. And if you do really something expensive, it always helps that you see it the right way. And if you are virtual reality there, it looks like you are in the real nature. Okay, on the right side, This is old stuff I do for our Independence Day, which is always in the Christmas. Looks like virtual reality, but it's a real picture, no Photoshop there. And here on the left side, our design is Lumo, or the T2 design is Lumo Chaga. Our office is there behind. Yes, it's a smart part. You hardly see it. It's practical to take and put on the lumina there. Yeah, that's smart. Okay, any questions? Thank you.